Imagine your applications are talking to each other, sharing important news. What happens if one of them misses a message or the connection briefly drops? How do we ensure those critical updates always get through, even when things are a little bumpy? Retries significantly improve webhook fault tolerance by automatically reattempting failed webhook deliveries, ensuring messages eventually reach their destination despite transient network issues, server downtime, or temporary processing failures at the receiving end. The core mechanism behind this improvement lies in the nature of distributed systems and network communication. Webhooks are essentially hypertext transfer protocol requests sent from one service to another. In the real world, these requests can fail for many reasons. A brief network hiccup, the receiving server temporarily being overloaded, or even a short deployment window. These are called transient failures. Without retries, such failures would mean the message is lost, leading to data inconsistencies or missed events. Retries anticipate these transient issues by giving the system another chance to succeed, acknowledging that not every failure is a permanent problem. To effectively implement retries, several strategies come into play. A crucial one is using an exponential backoff algorithm, which means waiting for progressively longer periods between retry attempts. For example, after the first failure, you might wait for 1 second, then 2 seconds, then for seconds, and so on. This prevents overwhelming the receiver with repeated requests if it is genuinely struggling. You also need to define a maximum number of retry attempts and a total timeout duration to avoid indefinite retries. Furthermore, the receiving endpoint should ideally be idempotent, meaning processing the same webhook multiple times has the same effect as processing it once, preventing unintended side effects from duplicate deliveries. An advanced aspect of robust webhook design involves distinguishing between transient and permanent errors. While retries are perfect for transient issues like a 503 service unavailable status, they are ineffective for permanent errors such as a 400 for not found or a 401 unauthorized. For these permanent failures, retries would only waste resources. This is where integrating with a dead letter queue becomes invaluable. A dead letter queue holds messages that have failed all retry attempts, allowing developers to inspect them, understand the underlying permanent issue, and manually intervene or trigger alternative processing flows. By strategically implementing retry mechanisms with exponential backoff, maximum attempts, and leveraging dead letter queues, you transform your webhook communication from fragile point-to-point connections into resilient, self-healing channels. This ensures that your applications remain synchronized and your data integrity is maintained, significantly enhancing the reliability of your entire system even when encountering the inevitable unpredictability of network and service interactions.
If this helps you code smarter, like, subscribe, and stay tuned for more.